Okay. Now, when you declare a variable as constant, all you're doing is you're just telling the system that this value is not to change. This value pi, for example. So if something tries to change it, it'll generate an error, basically. And that's the only use it really has. It's not treated differently as far as it being memory or what have you, except that a constant should be declared or stored in program memory. It should be, but it's mostly just used for as a safeguard. So for example, you can actually have a constant argument to a function, and if you do, and a variable is passed into it, either by by reference or by pointer, that tells the program to not let that value change, either be it the pointer or the constant. Now, normally, like these functions are passing by value, so if a variable is passed into it, it's actually making a copy of the value on the stack. But if you passed it in, as a reference, like for example, we can create a function that returns void, so it doesn't return anything. My function, have it accept an integer, but say x, for example. Now that ampersand, is a is a copy of the variable by reference. Now, if I didn't have that on there, it would just be a copy of the variable, but we're actually passing it a reference to the actual variable, so it'll change the actual variable. But we could do something similar, by making it a pointer, and then we're actually dealing with the pointer itself, so we need to dereference the pointer. Kind of like that, or we could just go, and that's the same damn thing. Okay, and as long as we're passing it values like that, it has no problem. But if we go put the constant in front of it, and it gets a little tricky with pointers, but we put the constant keyword in it, it's not going to allow us to change the value dereferenced by the pointer, because that's what we're doing. We're dereferencing it. We're not modifying the pointer itself, but we're modifying what it's pointing to. I don't know if I can just put a value in here. Yeah, I can. Because I can't really just assign a value to a pointer. It's got to be a memory location, in other words, a variable of some kind. But we don't have any variables to work with here. Let me see if I can. Still can't do it, and it shouldn't let me do that because this is just be a local variable. But see, if I remove the constant, it still has a problem with this because it's a it's a local variable. So, well, hold on, it may not. I didn't do it right. You got to assign it the address of it. Okay, so. When assigning a pointer, you got to do it like this. All right. because you're changing the value of the actual pointer, the address it's pointing to. So you're going to use the address of operator, the ampersand, to point to it. Again, this wouldn't be a good idea because it's just a temporary variable, and I'm assigning our pointer from the outside to that temporary variable, and it will no longer exist after a while. Now, if I put it as a constant, it still doesn't have a problem with that, and the reason is because we've told it that it can't. We've essentially told it that it essentially can't change the the value of the pointer, that what the pointer is pointing to, but not the pointer itself. The pointer itself can still be modified. So let's see. Yeah, if we put constant there, okay, also, then that tells it that it can't change the value of the pointer. I may have put that in the wrong place, though. Let me see if that matters. Okay, so now, that's the right place, but let me see if the pointer can be put here. Okay. Now, I guess that's the right place for it. We might be able to put it there too. So I guess we could put it, either before the int or just around the pointer symbol, and that's actually a little better. So this is telling us that this constant here is telling us that the pointer itself can't be altered. Okay, because when I remove that, now we can alter the pointer value, or the pointer itself, but we can't alter the pointer value. So, but when I, delete this, okay, now we can't alter the pointer value, or the pointer's address, but we can, alter what the pointer points at. So, but again, kind of got the same thing with the reference or dereference operator, because I could say integer y as an input parameter, and the y minus or times equals 5, so it'll or 4, so it'll multiply y's value by 4. All right. But I could actually send this as a reference too, with no problem. Okay, so it'll still handle that just fine. But if I put constant, what the fuck? Now if I put constant in there, now it's going to have a problem with this, changing that. And the reason you have these in here, the reason you have these things in here is, again, you're basically telling your function that, hey, don't modify this, but you can look at it. Here, you're saying don't modify the pointer, but you can modify whatever it's referenced to, or, in this case, don't modify that, or modify what the pointer's the pointer itself. So, so because of that, that just kind of helps you, it helps other programmers understand when they look at this code that, hey, you're not going to modify this value, you're just going to look at it. So anything else you do in here, you know, could be considered to be modified or not, depending on whether it has a constant in it. That's called const correctness. So, you know, it's just a good idea, and it also, you know, gives you a form of error checking in case you make a mistake in your own code. So, you know, you may have a function that you do not want to modify a given variable or pointer or whatnot. So, you know, that's you know, helps you trap your own errors and your own mistakes. You know, in a nutshell, basically. I'm thinking I should probably comment this out. Damn it. Even though since I'm not calling that function, there's a good chance it would still compile because of the fact I'm not calling it. You know, so it shouldn't actually compile into the code because it's a, you know, if it's a dead function, it shouldn't compile in there. But you know, like a bunch of crap messages down here. Okay. Stop out. And by the way, okay, you know, you got debug and release, and it's always good to, you know, debug your programs in debug mode. You know, release code will tend to run faster, but, you know, it won't do a lot of the debug checking. So if you want to actually look at your, do watches on your variables and everything else, you know, you need to run a debug mode. I'll show you what watch variables kind of look like right now. You see you got autos, okay, and you know that's something that, you know, and you can only adjust some or turn some of these things on when you're actually in a debug session. You know, but you got watches, so you can watch, set up 4 watches to watch specific variables or what have you. But you got autos, which is what we're seeing right now, and that, you know, allows you to look, you know, at certain variables. Like for example, you know, we're seeing certain local variables as we execute the code. So these are the things we defined so far. So we step next, you know, we're seeing the various, oh shit, this steps out of whatever you jumped into, and this steps over something that may call a system function, because it'll actually step into, you know, any of the .h, you know, header files, any of the includes, etc. from, you know, BFE. So, you know, you got to watch that when you're stepping through, because it can be confusing. But you can always go into the call stack too. You know, like for example here, you know, you can look at the call stack, and this tells you basically where you're at in the program at any point in time. So, you know, this can get real carried away here. So, you know, you can see where we're calling from. So, it shows you which layer you're at. You know, whereas like I said, right here is where we really want to be. You know, that's our program, not all this crap. I didn't write that. So, anyway, we'll step out of that. But at any rate, you know, the autos, you know, are what we kind of look at there, the processes. So, so you can go to the disassembly but there's something wrong with this fucking program. You know, 'cause this is the assembly code for our program, and geez, I don't know where we're at on it, but okay, here we go. So this is disassembly, but I got no way of looking at the registers or the fucking, you know, or any of that other good shit. You know, the memory. I can't look at any of that, so you know, that makes this kind of useless a little bit. But anyway, that's a basic debug session. So I'll go ahead and stop that. Now, enumerations really are for pure programmatic purposes. They just help make your code more readable than anything. And they're really technically types, you know, so they're really type defs. So whether they're declared that way or not. So, you know, you can declare, you know, like a variable of type. I don't know. I still think you gotta declare it. Well, see, you know, you can do that, and you can set, you know, you can't use a dot operator here. You gotta, you know, I don't know if you have to use scope resolution either. I think you just set it to a given type. What did I set it to? Suite. Okay. So there you go. IntelliSense brings that out, so that'll set it to the enumerated value of suite. Now it starts 0, so clubs is 0, so I just really effectively set A, B, C, D equal to 0. So set it to yellow, which is 2. Well, maybe not. I don't know. Oh, that's looking at the wrong enum there. Set it to hearts, you know, which is 2. So, or, you know, I'm going to set it equal to 45. So, in enumeration, well, of course, actually, yeah, I can't do that, believe it or not, because like I said, it is a type def. So, since it's a type def, even though it's not declared that way, you know, I just said enum suite, you know, it really can only have these values in it, so you can't just arbitrarily set it to anything like you'd think, because we're not declaring it as an integer or anything, but I guess it implies that it is, based on the number of values you put in, because these really are integers. So, but yeah, you can't just arbitrarily set it anything outside of that type, so that's good. You know, again, that helps, you know, keep your program under control, so you can't just put any old value in there. This really does restrict the values you can put in because of its type set to suite. So that's new. I didn't really realize that, but that's actually quite true. So now the only difference between these two statements really isn't how they're declared, but you know, like I set charge electron to positive, so and I later changed it down here to negative. But you know, the only reason I had to do it this way is because I declared it as a type def with a type def keyword. But otherwise, if I just do it like this, the same damn thing. So you just don't have to use, it's less typing basically, and the order is different. type is declared there instead of stated here. So anyway, we know that doesn't work. Now, this right up here is a little puzzling. You know, this is code that I was entering in from that first book that I read, which really didn't explain things all that well. You know, pretty short book, but so I go like int abc int equals red. Okay, and since it's enumerated, I'm really just setting this integer, you know, to 5. See? So, you know, this is another way of using enumerations. In other words, I can, and this is the way I'm actually used to using it from like basic, Visual Basic. You know, so we're just basically making a bunch of words here, you know, and setting them to predefined values. But, you know, since int is an integer, I can set it to any value I want, as well as setting it to these enumerated values. But I can set any, ostensibly any variable, but at least any integer to, you know, like red, blue, green, or yellow, or black, you know, since they've been defined up here, to mean those numbers. But in an enumeration, a typical enumeration like this, I could do the same thing. I could assign, you know, like clubs equals 3. Okay, diamonds equals 5 or 6. Hearts equals 7. Okay, and spades equals 26. So, but basically, you know, so that assigns those numbers, but since it's a member suite, you know, I just really reassign the definitions of any of these numbers here. And that's kind of good, because that way, you know, this is like a tag, you know, like hearts, for example. So if I change the value of hearts, well, anywhere in my program is referencing the word hearts, well, the meaning of that will change. So that can be convenient, you know, for updating your code. So that's something to keep in mind. Now, in an enumeration like this, my understanding was, what the book said, was that you could only, you know, assign the first variable, but you couldn't assign more. But I don't know if that's true or not. It appears like it's not having a problem with it, so yeah, I mean, apparently you can assign it any value you want. So, although I guess they do have to be sequentially larger, I don't know. Maybe that's a requirement, I'm not sure. But if you don't assign it anything else at all, it'll start, you know, at 0 and work its way up, which is what we're doing in this enum. Enum, you know, we're starting at 0, and then this is 1. So, but again, it's just for programming, you know, and that's what we do here. This demonstrates that, you know, we're outputting to the console. That's what cout it means, console out. So it's only for console programs. But that electron, you know, even though we've got it assigned a positive charge, which is wrong, we reassign it to a proper negative charge here, which is right. The fact of the matter is that, you know, it'll still just print out, in this case, 1, and in this case, 0, but it won't put out negative or positive. You know, you'd have to use a, you know, a ternary operator or something to do that, like, for example, you know, so let's see, electron, well, I should, equals negative. Okay, and then go that, and then so this thing's going to like it because it's a cout statement we're using. It might have to go cout negative. Well, I can't go cout negative. Okay. You know, these shift stream operators or whatever are touchy about that. So let's press F5 and run the code and see what happens. Okay. Geez, here we go. Scroll up. Okay. Oops, electron is 0 charge. Oops, electron is negative charge. Okay. So, you know, electron is 1 charge, electron is 0 charge, and then I go, oops, electron is negative charge. Okay, and that's the part of the code we just modified right there. So, you know, basically, you know, this is what we just wrote. So, you know, the ternary operator in it, and that's the only way to really get that to the screen, you know. So like I said, it doesn't do you any good to have it enumerated because it won't print it out. You know, it's still just a number, you know, in the end. You know, but for a programmer, you know, that, you know, is not only more descriptive or more readable code, but, you know, it also does help you do some error checking and so forth. So it's actually just good form to do it that way. So, anyway.